everyone. Welcome to our presentation. I'm Yağmur from Electrical and Electronics Engineering. Let me first introduce my team members before I start the content. Abdullah Taha, Fahrettin, and Doğancan.
Yeah.
And we will introduce our possible datasets. I will start with the sign language dataset. Next, please. I would like to give a little information about the American Sign Language. It's ASL. As you know, sign language has many variations. We choose American Sign Language because of the more reachable. Probably, could you take the slides previous one and another previous? Thank you. You will one more next. Yeah. I would like to see the Kaggle page. Thank you. We will see the minus J and Z in this dataset. Because of the motion issue, let me show you to everyone. It is J, it is Z. We would like to use the image processing in our project, but if we add J and Z, it will include video processing, and it is not our aim in this project, so we will not use J and Z signs. Next, please.
Okay, I will continue from that one. The situation is why we should this project and what is the importance. Sign language is an important communication tool for people with hearing impairments, and with that, sometimes we cannot have an ability to touch a keyboard while we are trying to search something else. With that project, we can focusing on the problems of that. Next slide, please. Okay, what is ML tasks, I guess, by this data set? Our project involved processed images, and with that processing image, we want to recognize letters from the machine. With that, since we had labeled data, it's basically supervised because every letter corresponded to each image. When we want, and then with that we want to use that technique to train our model, and with that, in particular, as a task, want to classify each image into corresponding letter. We use the classification algorithm to achieve this goal. So it's supervised, and we use classification algorithms. Next, please. Okay, and in our data sets, we have this amount of data and this amount of features in our data set.
Features in the picture.
Sorry. Other slides. Yes. What are the classes? Our dataset includes photographs for sign language, letters from A to Y, from taken in the language, from taken in the angle, and G and Z are not included because of machine issue. What Yağmur polarized mentioned that other picture, Yes, we'll continue. Okay, so what are the features of data sets? We use image embeddings to improve the accuracy of our classification tasks. And what is image embedding? An image embedding is a lower dimensional representing of an image that prefers important visual features and can be created using pre-trained CNNs. By using image embeddings, we could feed the lower dimensional representations of the image into our classification algorithm, which we use. And it is easier for the algorithm to learn patterns that discuss one letter from another, to find which letter is which one, and to find what the users is doing. Okay, you can go other page. And we want to look our flow. It's simply like that. We are inputting our images, we are embedding them, we are sampling them, and we are using test soccer with luggage registration. There's not an issue, but there is a sign of issue. It's basically saying that it is not working properly. It cannot be dealing with, I guess. We use that method, but it's on the way, I think. And we had our results and other slides. You can move on other slides. Yes. On other slide, we are basically saying that program can understand which sign is which language and which sign isn't which language.
I'm sorry.
And we basically think that it's working properly. There are some possible issues, but the program can learn and work with that issues. So we can move on that. Under slide, you can pass other slide. Okay, my part is over. My friend will be move on.
I will be continue from there. There are not missing values to delete, but we need more data because, as you know, sign language may change the even person to person. That's all for this page. Next, please. We have some understandings from here after our test. Most significant factor is light and background, as every image processing issue. Sign E and sign S has a really high rate of confusion because of the similarity. It is A and it is S. We was expecting these values. X and Y signs are most distinguishable signs, and it is labeled, so it is supervised and multi-class, and we made a classification in here. And that's all for my part, and we can get questions.
Okay, thank you for the good presentation, but I would like to highlight that if you are interested in image processing, then I think it's not going to be suitable for our purposes. Why? In our class, we will learn mostly machine learning techniques and how to augment data, how to use data transformations, etc. But for the conventional data structures, I mean that tabular data. Okay, so here we are using image data. It's not gonna be easy for you to transform or to translate what you are learning from the class to your project. For example,
Teacher, for that we have other projects with raw data.
Therefore, for example, if I ask you how to implement the data augmentation, you need to implement the image data augmentation tools. And I don't know if Orange tool supports this perfectly or not, because I didn't use the image package, okay, tool set. So I strongly suggest you to decide if you want to move on with that project, or you have I know that you have a second project proposal, or you want to switch to second one. Which one? What to do?
Okay.
What do you prefer to do?
Actually, we want to work on image processing, but
Yes.
you know, it's cool. But Carface is more, it has more reality, you know. There is some values and we can work on it easily.
Yes. So what is your second proposition?
Yeah, then we continue on that.
Okay. Okay, I am listening to you. Please.
Second project is a car sale helper for Russia. Next slide. It's aimed to sell in the right price range according to feature of the second-hand cars for people. To offer a price range in the accordance with the features that people who will buy a second cars want. Next slide. How many samples? We have 3 million samples in both files. 1 million 500,000 sample in region 25 and 1,500,000 sample in region 41 and 13 features and 4 metas. Next slide. What are the features? To put it briefly, year, color mileage, horsepower, engine capacity in liters, price, and rationables. Categorical features are car color, car body type, full type, type of transmission of the machine, the car brand name, and city of announcement. Daytime features are date of publication of the announcement, date and time of receipt of information about the announcement. Next slide, please. We have select some features which are year, power, mileage, full type, and engine displacement, transmission, and color. Totally, 1,130,000 rows have missing value in our data sets. Next slide. In which features, as you can see, most missing features are year and engine displacement. Next slide. Abdullah will continue.
Yeah, hello everyone. I'm gonna analyze the data for you. This is our flow to analyze. I take a screenshot for some features because we construct some to analyze visually, to show you visually. Machine can understand, but we cannot. Some features, some correlations. We choose those features to analyze. Year, power, mileage, location, brand, fuel type, engine displacement, transmission, body type, color, and date is important because if you want to predict a price, if you want to suggest a price, it depends on the inflation. Our target is price, as you can see. We just analyze region 25, region 25 file, and we filter data. All variables must be defined. And the data sampler only gives next widget 6,000 data, 6,000 row. We derived price log 2 to taking logarithm, 2-base logarithm of price, because expensive cars are rare, and it affects visual, it affects graphics. It makes graphics to hard to understand. So we derive that feature and we assign it as a target in here. And we have engine displacement because it's categorical data, because it has text. We filter text and turn into float, and we use engine displacement as a float. This is the normal price projections. As you can see, power year, power year, and engine displacements is the most relative data to the price. This is prices scatter plot. As you can see, price log is more visible, more understandable here. Most relative data is mileage and year, as I mentioned, because correlation between mileage, year, and price is high, because there is so much feature, not that high. It's under the 0.9, but there is lots of feature. And correlation data is engine displacement and power. You can see it's hard to see, 0.8. Those are the high correlation graphics. Now my part is over.
I will
It's also.
from there. As I will mention about the understanding. As the year goes up and the miles goes down, the price affecting and goes up. As the year goes on and power increases, the price goes up. But most cars' engines are in 350 range, between 50 and 350 range. Most high priced cars in the between 6 display range. And we will use regression and classification models will apply to this dataset, but mostly we use regression. And we use, of course, a supervised learning model because we use labeled data. That's all. Could you change?
Any questions?
Okay, the second data set is much more suitable for our purposes in that class, okay, in that course. But I have several questions. As far as I've seen that half of the data is removed because of the missing data. Am I right?
Yeah. But there is.
Can you show this slide? 4 slides ago. Go back.
That animation, sorry.
Go back. Yes, here, for example, you are talking about only 600 left, right? On the next slide.
We reduced 6,000 because of the observation purposes. Because higher data takes more time, but we also observe with another data, another samples. It gives us the same results or slightly different results.
No, I am not talking about result. I am talking about size of the data set. After removing the missing data set on the next slide, you are saying that only 600.
Not 6,000. It's actually 500,000 because
You are losing 1 million of the samples. Am I right?
oh, sorry. We lose 500,000. We mentioned another slide. Let me turn back to that slide.
Here.
Yeah, we have a million row have missing values, but we have 2 million. Still, we have 2 million. It's enough to our purpose.
Okay. There are some, I think, contradiction in your presentation. In somewhere you are talking about this number of missing 1 million. In somewhere you are saying that this number 600,000 left after you
as I said,
filter out.
As I said, we only work on region 25 file because the data is too high to observe, too high to process on our machines. So only region 25 data.
Okay. Now please go
is the 500.
One back.
Okay.
Now, Yağmur.
Yes.
How can you deal with the missing data? Have you checked this? What are the mechanisms or what are the proposed methods to deal with the missing data? Have you checked this?
No.
No?
Actually, image processor, I was really into image processing stuff. So I mostly worked on the image processing database. I'm so sorry.
I see. But as you noticed that there are very many samples have with missing values. So Fahrettin, have you checked? How can you handle missing values?
Actually, we can predict the missing values to be getting big enough to deal with
This is one
our data.
version. Yes, one way. Another way.
Actually, I don't know other ways because I thought that we simply have 3 millions and we can. I just thought that we can lose 1 million. I don't know.
It's not a good idea to lose one out of 3, right? It's not a good idea.
Yes.
In machine learning, it's not a good idea, right? Doğancan?
I think the 2 million is enough. I think.
Okay,
but
it's not enough. But I am asking that if you are losing 1 out of 3 samples, it's not enough to what is rest. Okay, so shortly, I mentioned here that please concentrate on the methods to deal with missing data. Okay, read more about this, and you need to implement in your project these methods. Okay, actually these methods are provided in the orange tree as widgets. Okay, you can use these widgets, but you have to learn and understand the meaning of these methods and their advantages and disadvantages. Is that clear for everyone?
Yes.
So in your next presentation, explanatory data analysis, I expected you would talk more about how to deal with these missing data. All right? The secondly, at the end of the presentation, you mentioned that we are going to use regression and classification machine learning methods. But here, what you are going to try to predict? The price of the car, right?
Yeah, maybe we can divide into ranges, as you mentioned in the flight price.
Oh, okay. Maybe, but you need to be specific about your goal, and your goal is or must be related with your output. So what is your goal? If your goal is to just predict the nominal value of a car, then it's a regression. But if you want a expensive, very expensive, cheap kind of cars, you need to then use the binning approach. So you can use the discretize widget to discretize. And the second, in the slides, 3 more slides ahead, you have some present this slide. No, one before. In the orange tree model. Okay.
This slide?
Yes, this slide. Actually, I don't expect you to present this slide because there are some discussable, arguable points here because I will teach during the class, okay, coming weeks. There are several things that we need to discuss later. But in that presentation, I would like to see that can you relate the features with the target value or not? Okay, so you could provide, right, the box diagrams, for example, so that if the data is, the target data can be predictable by using some features. I would like to see that in your exploratory data analysis presentation much more. We don't focus on prediction yet. We focus on data, missing data. How can, and is there any outliers? I believe that in the price, if you go 2 slides later, there are some outliers. So you need to read about outliers. There are some prices very low, very high. You see that? Very low.
Yeah, so
Yes.
we take
How can we
logarithm.
handle this kind of prices? They are called outliers. Please note that you need to explain me how you are gonna deal with outliers in your next presentation. Okay?
Actually, there is an outlier widget, sir. We use that, but it's not help us to our target, our goal. So we
keep reading,
use the logarithm methods.
Keep reading methods and apply your methods, whatever you learn, during your project. Okay? And mention in your report what you implemented for outliers, what is the, so, okay, we are just have 10 minutes to finish, but in your report, please mention what you have used, what was the impact. Okay?
Okay.
Any question from the audience? Anyone would like to ask the team? Okay. Overall, it's a good presentation. I hope that in the next presentation, exploratory data analysis presentation, you will talk more about data and relation with target, the price.
Okay.
Okay.
Thank you so much.
Thank you.
Thank you. Thank you.
Thank you.